Now that we've looked at sort of the broad picture of what Searle is after, remember he's talking about intentional states, right? Thoughts of, consciousness of, cannot be produced by a computer in the specific sense of programming, but certainly their intentional states can be produced by physical mechanisms because our brain is a physical mechanism, and not only are physical mechanisms sufficient for producing these intentional states, they're necessary, right? You don't have intentional states outside the physical universe. There's no sense to that. So again, there's no mystery mongering. He's just trying to say that intentional states are localized in a certain kind of architecture, a physical architecture. Keep that in mind. Okay, so how does he do this, right? How does he get the, how does he limit, or shall we say exclude, computers from being places where you have these intentional states? How does he do that? Well, here's his thought experiment, sometimes called the Chinese room experiment. Again, the language doesn't matter. It's just you want to imagine yourself or a person in a room where they don't know, that person doesn't know any Chinese. So in other words, when you look at a Chinese script, when you look at it, it's meaningless to you in the sense you might recognize that it's Chinese, but you can't say what anything means. You can recognize when two Chinese characters are the same. Yeah, you can pick that out, but you still can't tell what they mean. So you can correlate them, right? Say that one's the same as that one, but in a very rudimentary way, just by saying, yeah, they kind of look the same, but I haven't a clue what they mean. And maybe you're not even that good at that because those symbols, if you look at them, are pretty complicated, and that's a real skill to be able to recognize that as well. So again, you know nothing of this language, but you know English. Okay, so again, doesn't really matter. You could flip the languages around. You know Chinese, but you don't know English. It doesn't matter. The point is one language you really know, and the other one you don't know at all. Okay, so let's go with this. So you're in this room, you don't know Chinese, but you do know English. You're getting batches of Chinese script sent in one little opening, and you produce outputs. And what you're doing in a sense is you're given a batch of Chinese script, batch one, batch two, and batch three. And you're also given rules in English of how to correlate symbols just to line them up. So it could be just a rule like when you see this symbol or these five symbols, you will take these three symbols and put it next to it, so that you would able to produce, as they say in the computer, as output, strings of Chinese symbols. But again, you're just correlating them. So it's like put that, I mean, another way to think of it is you're putting that shape, right? That uninterpreted shape, haven't got a clue what it means, uninterpreted. I'm just according to these rules in English that say put that shape with that shape, put those shapes with these shapes. So you're able to do that. Okay, so you have rudimentary abilities to recognize. But again, if I say, what do the shapes mean? What does that string of Chinese characters mean? I haven't got a clue. So the batches that are coming in, you don't know what they mean. The batches that your outputs, you don't know what they mean. You just know how to string, literally, you just know how to string all this stuff together. Now, and so, but what you don't know is that these batches actually, because they're written in Chinese and they're not just random, it's real Chinese. So in other words, somebody who knows how to read this would say, oh, well, what you've actually got, you're calling them batches. Really, what you've got is you've got a story in Chinese and questions about the story, and so that's what they fed in, and what you produced, your outputs were, and I put in scare quotes, were your answers to the questions. And you're like, I didn't include, is that what it was? I just got this, all these characters just came in, right? All these, and I was just putting them in a certain order and pushing them out to the output, and I have no clue. But at the same time, you are not only getting these batches of characters in Chinese and you're just firing them out. Then let's say you get pretty good at this, right? So the programmers so in other words, the programmers are, let's say, people who know, of course, they would have to know Chinese. So the people that know Chinese are programming this with the rules, right? That's the program, right? So you're operating according to these rules. So you're functioning like a computer, Searle says. You're basically doing what a computer does because you feed the program in, right? So the people who know Chinese are programming you. You're reading it. You're instantiating the program by correlating the symbols. And let's say after you do this quite a bit, the programmers get really good at writing these rules for you. You get really good at mapping it such that you get so good at it that when they're feeding in the stories and the questions, right, you haven't a clue. You're just rattling off and shoving these strings of Chinese symbols out the output. And again, another person reading them who knows Chinese, who thinks, yeah, you really understood this story well. To them, they would be reading your output as language, as a living language, right? Not just a series of strings. And let's say, again, just to ramp this up, Searle just keeps cranking it up, you can imagine that after a while, the programmers and you get to be so good that we put another room with someone who understands Chinese, give them the same sets, and they're reading it. Of course, they're not going to need the rules because they understand Chinese. So, but your output is indistinguishable from theirs. In other words, I don't know, the teacher comes along and grades both of your papers, and you do just as well as the other person who's fluent in Chinese. So you become indistinguishable in terms of your output from somebody who's fluent in Chinese. Now, Searle says, if this all goes through, what do we get out of this deal? It's quite interesting. He says that after you become sort of this indistinguishable from someone who's in Chinese, and you're producing answers that are as good as someone who's fluent in Chinese, and maybe the Chinese person who's fluent in Chinese is doing the same thing in English and is producing English answers as good as yours. You guys are indistinguishable, and yet you're producing answers in a language that you have no clue. It's just completely to you, the Chinese writing and all that stuff. You can't even tell the difference between your output. Like, you wouldn't even know that you're providing answers unless I told you. You wouldn't even know that you're given a story in Chinese and you're answering questions, a story with questions, and you're answering and you're doing really well. You have no clue of all this, but you're able to produce all these quote-unquote answers. But you're just working for you. The Chinese writing is uninterpreted shape. When I give you the story in English, though, it's not uninterpreted. I wouldn't need to program you. That sort of, I don't know, maybe some weird way has already been done or whatever. But you certainly approach the English writing very differently, right? You may have no clue about that stuff, but you approach it in a meaningful way. So that's what's going on, according to Searle, in this experiment. So what's going on for you with the Chinese writing? It's just uninterpreted symbol manipulation. It's not even really a symbol, just shape manipulation, right? Just shape correlation. So in other words, this is just computational operations on formally specified elements. That's all that's going on with you, right? So I put a little asterisk here. So this is what's going on. So Searle says, well, you're basically functioning like a computer. No intentional states, indistinguishable from the outputs of someone with intentional states, right? The person who knows Chinese, they have intentional states. They're actually producing answers. You're producing answers, but the answers and the answers are, in the end, indistinguishable. But one has intentional states and one doesn't. So don't get so carried away just because a computer can produce answers that those answers are answers. Big difference, right? Even though they're indistinguishable when we just observe them and read them. All right, so that, Searle thinks that puts kind of the nail in the coffin of strong AI in the sense of computational operations on formally specified elements. This symbolic manipulation, that's what's going on in your laptop. That's what's going on in a standard computer that's been programmed. So you want to call that weak AI? Go ahead. Don't call it strong AI because that's not a mind in there. Now, needless to say, philosophers and computer scientists aren't going to think that's sitting down. So, and I'm not going to go through all of it, but Searle addresses a number of replies, all very interesting. How do we understand the notion of an intentional state? And so we can dig right into all of this. But Searle thinks in the end, he can respond to all of them. Have a look at it, see if you agree with Searle. But Searle wants to end on some reflections. And he's like, don't get carried away. There's nothing mysterious here. Symbolic manipulation is just part of what we do. But let's just remember, there's always that distinction between syntax and semantics. Syntax is like grammar, rules, right? You can teach computers these rules. You can follow them such that you can produce strings that look like they have a semantic content. And they do to someone else who actually understands the strings and doesn't just see them as uninterpreted symbols. So you can work on the level of syntax in the Chinese room. That's what you're doing. You're working on that level of symbolic manipulation, but you're not up on the level that you are with your English, right? And same thing for that fictional person who understands Chinese, who doesn't understand English. It's the reverse for that person. She would be over here in the Chinese writing would be all meaningful, and the English writing would just be squiggles and shapes that she's just linking up with her programming. So her programming, the English would be the stories and all that stuff, and the programming would be written in Chinese, and she's just firing out the strings of English, not having a clue what they mean. But her answers are just as good as yours. So Searle says, okay, look, with all this, let's not get carried away. There's nothing mysterious here. This capacity that we have, our brains have to understand, we'll call it the CU. Can a machine in principle have CU? Yes, no question. As a matter of fact, it has to be a machine, right? It has to have some level of complexity, and it has to be physical. So physical complexity, machine, CU, absolutely, no question. And that's the only place you're going to find it. You're not going to find it where you don't have the right level of physical complexity, and you're not going to find it unless you have a physical complexity. Does a machine working in this way have CU? No. So in that sense, if you just keep programming and programming and writing more, you can write incredibly complex programs. Go ahead. You're not going to get a mind popping out all of a sudden. That's not what Searle thinks. That's what Searle thinks. You're not going to get a mind that pops out and say, well, I made a really, really complex program and just that does this. Like you can make this extraordinarily complex, right? Think about it. You could get to the point where maybe you're analyzing, classic Chinese poetry, and you could answer all kinds of sophisticated questions about it if you really have good programming, right? If those programmers are really good at that, you could look like a scholar of ancient Chinese literature, and you haven't a clue what any of it means. No mind there, not in that sense. Can non-human physical structure, this is kind of repeating, but I want to drive the point home about Searle is not mystery mongering in any way. He's trying to demystify the whole notion of this, and that it's physical. So could we encounter Martians that have capacities to understand? Sure, yeah, that's possible. That's an empirical question. So non-human physical structures having capacity to understand? Yeah, that's an empirical question. And he says it kind of wants to sort of downgrade it all, or at least take all the mystery mongering out by saying, look, why don't you ask something like this? Could photosynthesis, right? The stuff that's going on in plants, whether they're making food and all that stuff, could that be done without chlorophyll? Could you have a different kind of chemistry that produces photosynthesis? Sure. Are you going to get photosynthesis without any chemistry? No, of course not. Are you going to get photosynthesis without a sufficient level of complexity? No, you're not going to get it in just a bar of steel or something like that. It doesn't have enough complexity. But could you manipulate and a physical architecture in such a way that you could have a chemistry that's not like what we know regarding chlorophyll and produces photosynthesis? Sure, go check. It's possible in principle. You might look around the universe and not find it. It could very well be that you look around the universe and you don't find the capacity to understand like us. Okay, but that doesn't mean that it's impossible in principle. Just maybe it hasn't happened yet, or maybe it did and we haven't found it or something like that. But the point is, it's all an empirical question. All right, so there you go. That's Searle. He thinks he's taken down not machine thinking per se, but the idea that you're going to program in this sense using computation. You're going to put computational operations on uninterpreted symbols and eventually get a mind out of the deal. Searle says, not going to happen. Can you have Martian minds? Sure. Can you have machines that think? Sure. But they're not going to be like this. They're going to be more like that.